Okay, so we're starting the next unit, which is polynomials. We're going to learn about how to factor polynomials, which you're going to need for the grade 11 college credit. Okay? So before we start with expanding polynomials, we're going to start with defining polynomials. Okay? So the first question that we're going to ask ourselves, what is a polynomial? So polynomials are terms that have variables to whole number exponents. So the important part here is that it's a whole number exponent. Okay? So you have a variable. A variable means it's a letter, okay, with an exponent that is a whole number. Okay? And it also has to be a positive whole number. So add to this a positive whole number. Okay? So when I look at 5x cubed, for example, that's my variable. It's right here. And the exponent on the variable is 3. 3 is a positive whole number. Do you guys agree with me? Right? So I can say that this term is a polynomial because the variable x has a positive whole number exponent. Okay? That number that comes before the x, we call that coefficient. We've talked about coefficients before. Right? So I have the coefficient, which is 5. I have the variable, which is x. And I have the exponent, which is 3. And the exponent is a positive exponent. Now, let's look at the second term that I have here, which is negative 2x to the power of negative 1. Is this a polynomial?
No, because negative 1 is not a polynomial.
That it's not a positive number, right? So if you look at this one right here, this number here, the exponent is a negative exponent. The minute that the exponent becomes the exponent's negative, it's not a polynomial. Okay? For it to be a polynomial, it has to be a positive whole number exponent. Do you guys understand that? How about this? This is also not a polynomial because the variable is in the denominator. So for this variable to be in the numerator, right, that would be 7y to the power of negative 2, right? So technically, the variable should be in the numerator, okay? The variable should be on the top. It shouldn't be at the bottom, okay? So let's look at this. So I have 7x squared minus 4x plus 2. How many terms do you see here? 3 terms, right? So this is one term, this is another term, this is another term, right? And then you're either adding or subtracting between the terms, right? You see that? All right. Your first term, what's the coefficient of your first term? 7. That's a coefficient. And what's the degree? What's the power? What's the exponent? 2. Your second term, what's your coefficient? Negative 4. And then what's the degree on top of the x? 1, right? If it's not there, it's 1. Yeah? And then what's the last term? 2, right? There's no x, but technically, if you want to have an x, it will be x to the power of 0, but we don't usually write that down, okay? Because x to the power of 0 is 1, and we don't usually write that, okay? But technically, there is an x that has a power of 0. We ignore it. Now, the first one, the one with the highest exponent, we call that the leading term, okay? So this is your leading term. And it has a degree of 2 because that's your highest degree, right? So we call this polynomial degree 2, okay? So this is a degree 2 polynomial. because the highest degree is 2. Okay? You guys know what a word degree mean, right? It's the power, it's the exponent. Okay? They all mean the same thing. And we call this term a constant term because it doesn't have a letter associated with it. Okay? It's called the constant term. So I'm going to just go over the names of the polynomials. Okay? So the names that we use for polynomials are the following. We have a monomial. What does the word mono means? Single. So that's equal to one term only. Then we have binomial. That's 2 terms. That's where the word bi comes from. And then trinomial. That's 3 terms. And then anything above and beyond tri, we just call them polynomial. Okay? I can still call these polynomial, right? But there are specific names for them. Okay? But anything beyond the 3, we just call them polynomials. So that's greater than 3 terms. And remember, I can't call it as something nomial unless it has a positive whole number exponent, right? Or it could be just a number by itself. Remember that, right? So we call that a term as well. This is also called a polynomial, monomial. All right. What? By itself, yes. If it's by itself, like for example here, I have a monomial right here. So this is a monomial, right? Multiplied by how many terms in this? 2, so multiplied by a binomial. Okay? This is what I have here. I have a monomial, so 1 term by itself, multiplied by a binomial, which is 2 terms. Okay? So remember we talked about this before. We talked about how can I simplify this, right? We talked about the tacos and the pop. Remember that? And we said that in order for us to be able to expand this, we're going to have to use the distributive property, which is multiply the monomial by both terms inside the bracket. Do you guys remember that? Yeah. We talked about the combos, right? So for me to expand and simplify, so the question will say expand and simplify, or simply simplify, okay? So what I have to do here is I multiply that monomial by both terms inside the bracket. So that's going to be 3 times x, which gives me 3x, and then 3 times -4, which gives me -12. And that would be my final answer, okay? So remember we said that whenever you have 2 tacos and 1 pop, but you want to buy 3 combos, right? So that gives you 6 tacos and 3 pops. Remember that? Same idea that I've done right now. Are we okay with this? Okay. So Again, what do I have here? 2y, which is a monomial, right? It's by itself. It's one term, right? Multiplied by binomial, okay? So a monomial multiplied by a binomial. What do I have to use? The distributive property, right? The distributive property, okay? So that means I have to multiply the monomial by the first term. So what does that give me? 2y times 3y. That's right, 6y squared. Let's look at what happens here. Okay, eyes on me. So I have 2y times 3y. Yes? So when I multiply the two terms, the 2 and the 3, they multiply. So 2 times 3 gives me 6. And the letters, because they're the same letter, right, I have y times y. We talked about exponents. Remember, if something is multiplied by itself, I can raise it to the power of how many times it's multiplied by itself. So in this case, I have y and another y, so that would be y squared. Remember that? Remember when we talked before, if I have y to the power of 4, that's the same thing as writing y times y times y times y. But then I don't do that because that's too long, right? I can simplify it using this. Same here, right? I don't write y times y because that's simply y squared. Are we okay with this? So I multiply the number by the number, and I multiply the letter by the letter. That will only work if they're the same letters. They have to be the same. It can't be like x and y. Then I have 2y times 2. What does that give me? 4y. Right? Because I have 2y times 2. Number times the number, that's 4. And then y is by itself, so it's y. Are we done? Yes. Why not? They're not like terms, are they? No, they're not like terms. Look at these two. What does it have to be for them to be like terms? What must they have? Same letter and same degree, right? I have the same letter, but I don't have the same degree, right? So I can't do anything with them. They're not like terms. I have to leave them separately. Okay? Yes, so the 2y multiplies to each term inside the bracket. Okay? For which one? For the last one? Yes, because there's no other y. Okay? So here's, I'm gonna show you what's happening here. So I can write this as 2y times 3y plus 2y times 2. So what happened here? 2 times 3, that's 6y squared plus 4y. Okay? You okay with that? All right. So here's some